Okay, so hope you recovered a bit. So XML JSON, XML you knew already. Perhaps you know the difference a bit more now to JSON. So JSON very on the simple side of the end, and yet we have YAML, yet another language, right? So why do we need yet another one?
This one is easier to use for configuration files.
Why?
JSON could be just one long string, and YAML is more human readable.
That number one. So what are you referring to explicitly there? There's the magic is in there. What do you mean with human readable? Why is it? Because you could write JSON like YAML formatting as well, right? So what is specific about YAML?
You have to have it in a certain human readable format with indentation. And
there you go, right? So it does Python style indentation, right? Yeah. So it requires it. So it substitutes the parentheses with indentation. So it makes it, here's an example, much more readable, right? So you don't see any parentheses, but the indentations and positioning is very important, right? So signifying, for example, enumerations as opposed to relationships, and this one here being some sort of structure that captures the rest here. This is actually Docker Compose, of course, file, favorite ones. One of possible application cases, but you see it's kind of really human readable, as you say, right? It's quite straightforward. Cool, so that's definitely one of the features. And I think, yeah, most of the answers were given and the slide I just showed. But so why do we need this thing as well? What's another reason? Well, it has a bit richer feature set. We get into that. So basically, conceived in 2001 already. This is totally industry driven, right? So whereas XML is totally consortium driven, right? World Wide Web consortium. JSON is kind of really from ECMA group, the guys that standardized JavaScript, right? This one is just 3 guys, right? So kind of they're all across a different spectrum. So they of course have industry background, and they actually. I think the middle guy comes from the Perl community, so very kind of important scripting language, I guess, in the 80s in particular, and still relevant, has some relevance up to today. But so that shows a certain inspiration. The idea was there: can we come up with a language that has kind of evens out the differences or the challenges that people can have with JSON on the one hand, and getting some of the feature set back that we have in XML. And find a compromise that is super human readable, right? And that's exactly the point. This is part of the reason why it's pretty much used in any modern configuration file conception, right? You guys saw it already in Gradle, right? So we use it in this course, of course. In Docker, very much so, Ansible, and many of the continuous integration toolchains and DevOps tools usually fall back to YAML configuration files, right? Because it's just more readable than JSON by getting rid of the parentheses. So latest variant of this one is from 2009, so also fairly stable now. In fact, all the formats we talk about are fairly stable, so that's fairly good. So what the principles are is basically column-based separation. Indentation is, of course, super important. You have a nesting conception, which is signified by indentation, similar to Python, right? So different levels of indentation. You can have enumerations as well. You can have rich data types. That's pretty cool. So actually you can have extendable data types that you also principle also specify, but otherwise will be passed. You get back the relational anchors thing. So the idea that you can reference between different entries like you have in XML, which you don't have in JSON at all. So you can encode this again. That's pretty nice. Yeah, strings without quotation marks, so what? Yeah, well, good. And richer collections. In a sense, they can be order preserving. So you can actually indicate sequences as opposed to sets. Right, sets just whatever, right? The sequences has applied order. You have maps, ordered maps, and pairs as well. So it's a richer set of collection types that you get over JSON. Right? JSON is very simplistic, lists or maps basically, right? So without any implied order. So yes, so it's quite a bit richer there already. If we can see that. So different data types, they're generally auto-detected, but you can also type in them. So in fact, in many dynamically typed languages, coming back to that one, you can actually often type in. So even if you the system doesn't, you don't need to specify the type. You could tell the system the type is most likely. And the reason for that one is that the parsing will go a lot faster because it doesn't need to try different types when actually assigning the auto type, if you like, for example, but knows already, yeah, primarily you should try this type. Most likely parsing will work out, and only then fall back into assessing other types. So that's type hinting. You have it in languages like Clojure, which is like a functional language where you can do this, which is generally also dynamically typed. So, but here that's the way of actually indicating different types, right? So integer is like written like this. This would resolve to a string. This would be a float, and you can be explicit about the type specification by prefixing with exclamation mark and say, hey, this is going to be a float. This is going to be a string, right? So this makes parsing a lot faster, of course. And the classical Boolean that you have that you can use in pretty much any programming language. So you see it's a bit richer there, right? So in terms of specification, but super heavy on inline specification, right? So no schema, right? Not like an external schema like in XML, but actually it's an inline specification of types. So a different kind of approach. And one of the other things, of course, that it supports as well is comments. So per se, there's no comment conception in JSON per se. Of course, you can ignore certain, it's up to you. You write the parser in the end, but generally here's an implied comment component as well, which is cool for configuration files, right? Because you can say this means the following, so quite handy. XML has it as well, right? So that's unproblematic. But the other thing is also that it actually has different representations for the same thing for different purposes. So here, this is, for example, is a representation that lends itself better to streaming, for example. If you want to transmit data and streaming on the receiving end, then this is kind of the better way of actually submitting and serializing the data. If you ever want to read and have readable configuration files, well, this representation with the indentation probably makes more sense. So it's also more flexible for different purposes. Both of the other formats don't have that flexibility generally. Well, you can make JSON more or less readable. That's up to you, right? So, or you minify it so it looks horrible, but it's kind of not considered by design in a way, right? So YAML is kind of has been thought through quite a bit, in fact, but from a very practical perspective. Sorry. So if we look at it, it's kind of the middle ground. That's what I want to get across here. So it's kind of a middle ground between a really rich XML specification and the really fuzzy JSON specification, right? We have a lot more stronger typing. We can optimize. We can guaranteed readability because it's literally like in Python. It's very legible. Part of the magic has ordered collections, of course. But compared to XML, it's still weaker. It doesn't have tag conceptions or things like this. Doesn't have built-in validation. So there are external validation tools, but they are external, they're third-party stuff. Basically, if you want to specify, you would require a third party, the receiving end that has a different information system to require the same validation tool, right? So it's not like built by specification, it's built by convention. It's kind of a de facto standard to say, hey, okay, cool, let's do the following YAML specification and use this tool to validate, to ensure that we actually have the same validation on either side, right? So it's not as rigidly controlled as it is in the XML case. So since it's richer in its structure representation, you can do a partial conversion to XML. So that's quite nice, right? Back and forth and so on. So it's a bit flexible there. It has the internal references, for example, as well, like in XML. But yeah, so in richer typing. So, but it's of course much more efficient again. I mean, that's quite obvious, simply based on the limited overhead, right? So you probably can encode it in a way that's even faster than JSON. Specifically if you take into account the typing here, the explicit typing. Because in JSON it's always a matter of trying out which type it actually fits in the end in your application, because it boils down to a use case. The parser doesn't just end by putting something into your struct. It actually ends up, or the deserialization de facto should end when you have it in a data type that you need for your application. Not just you got into the system, cool, I'm done, as opposed to actually I got into my application, because you need to do possibly type conversions or things like this. And that is expensive, right? So in here, type hinting can be in your favor. Anything else I wanted to say? No, I think that's it. I mean, the intuition should come across quite straightforward. It's just for you to decide, okay, which tool do I use for which purpose? Or which format do I use for which purpose? And that probably explains why people switch to different specifications for different purposes. So, up to now we covered 3 open, so they're all human readable. I didn't mention that, but I think that was implicit. Human readable representation formats, right? That can have different strengths and weaknesses. So now it's about exchanging data, right? So all of them are human readable. That usually means they're not so efficient on the wire, right? So it's kind of expensive to encode them. So for this purpose, there are some other formats. I'm not going too deep, but I want to discuss two of them. One of them is Beeson, the other one is Protobuffers by Google. Both of them, I think, are quite industry relevant. One of them because you used it already. The second one, we probably will use it in your professional future, I guess. So first one is binary JSON. That's basically the idea. A binary format version of JSON, right? Just geared for efficiency. So on the wire, it's much more concise because again, it's a binary representation. But it's not just compressed JSON. It's, more than that, it also has specification extensions. It's modeled around the data types are modeled around the C data types, and since most programming languages eventually end up in doing some sort of internal C representation, it's supposedly a lot faster to parse if you align with C types in the first place. That's what it does out of the box. And the data is internally organized since it's not just compressing JSON, but you can potentially shift and reorganize the elements. It's reshifted for easier traversability, and that's part of the reason why they came up with this format for MongoDB, right? So MongoDB internally is JSON representation, but if it's going on the wire for the sake of easy parsing, you rely on Beeson, for example. So, for example, what Beeson has, or binary JSON has, is it has payload information. So in the header, it declares already what the payload size is. So it gives a certain indication about how much you actually want to parse. If you do that in JSON, there's no metadata, right? You don't know, for example, thinking bookstore, you don't know how many books will be in that JSON file. You actually need to sequentially pass through the entire file to figure out and count the number of elements, right? So no metadata. Here we have metadata. Of course, that costs a bit of size, but from a parsing efficiency point of view, that is an easy trade-off to be decided. And you see another aspect here, it's really stronger on typing as well, because it doesn't want to waste time on matching types on receiving or sending, well, on the receiving side usually, and just provides additional types like a binary data type, something that's binary encoded already, just send it in a binary data type, date type, sorry, MD5 hashes, for example, and double representations that it forces as well. So it's quite neat there. So there's also some seemingly unorthodox decisions. For example, integers are always encoded in platform-specific manner. So it's 32-bit or 64-bit integers. Again, because parsing is a lot cheaper. It's more size on the wire, theoretically, but from a parsing point of view, it's much more efficient, right? So that's kind of the optimizations that have been built in to get this additional boost. Technically, you wouldn't want to worry too much about how that looks like. But just to give some impression of how the internal representation is, what data types are supported, right? You see, it's a lot richer already compared to conventional JSON, right? So you have binary, a string, double, int64, C string representations, unsigned and signed integers, 128-bit decimal, floating point representation, and so on. So it's a lot more extensive in terms of supported feature set than the conventional JSON. So that's the key idea there. How it looks on the wire, hang on, there's an example. I just should put it in my slide set, I guess. I'm just going to the official sites anyway. All the links to the sites are in the slide set in case you're interested and want to dig deeper and learn more. Yeah, so here's an example of encode. Of course, it's a very coarse idea, but here's how things would look like on the wire, and it's kind of nicely annotated, right? So you have hello world basically in JSON representation, key value representation. Here's some metadata encoded, like a document size. Here's the type encoding, how cool, it's a string, and here's the field value, and basically this is just a signature for indicating end of object. So kind of from a delimiting point of view, so to say, well, this is the entire representation. So it's somewhat concise. Binary, of course, but again, it has additional metadata. So that's the main difference there. So for you, shouldn't make much difference. You just bear in mind you can possibly, if you have a receive binary JSON and so on, use a library that directly supports binary JSON and ideally pass it directly into your data types. So basically you don't lose the inefficiency of going via JSON if you feel like it. So if you want to, for example, for convenience sake, pass JSON, that may sometimes be inefficient because you're using more weak, more coarse data types before actually converting them back to more strong data types, right? And if you can directly consume and produce JSON, you have this advantage. Again, part of the reason why it's used in MongoDB. So, cool. So there are other formats, by the way, that also encode JSON in a more efficient format. This one just has the edge because of its name. Because it feels, it seems to be related by association, right? Binary JSON, but there are a lot of other formats that do try the similar thing, optimize JSON for transmission because it's a hot format, and actually sometimes do a better job. But this one, the thing about it, when deciding about what to use, you need to think about also about compatibility. Whom are you using it with? What's the maintainability of this thing? And this will stay around because it's used in MongoDB, right? So someone has active incentives of actually maintaining it. So last but not least, certainly not least, is the protocol buffers by Google. So for the, most developments that actually come out of Google, Go is an example for this one, but such as proto buffers or Guava libraries and so on, usually come out of internal needs, right? Google need to connect their systems or want to do efficient interaction between the different components or information systems. And they usually develop something in-house because they have the manpower and the knowledge, and then generally provide it open source, which is kind of cool actually, because you get the kind of latest tech that is used used by one of the whales actually, right? This highly relevant technology, and in most cases it's a safe bet to adopt it because firstly it's maintained, secondly people just based on preferential attachment, they say, it's done by Google, so I use it as well. So the expectation that it has long-term viability is generally be justified. Right? It's not just some obscure super efficient format that 5 people on the planet use. It's usually a very efficient format that is actively maintained and used by a large number of companies. Right? So looking into those ones often makes sense, just for the sake of getting understanding, but perhaps also for the sake of learning. Okay, so Google protocol buffers. Just bring up the page briefly. Of course, it's all managed under the Google Developers umbrella. There's my mouse. So, there you go. Right, directly provided by Google, and the key thing is there that it's geared for efficient data transmission. That's the key idea there. So you have a very simplistic way of encoding protocol buffers or the protocol messages. So you see that on the left side. Basically, that's what you write in a human readable form, which is here the message person that has a certain number of required elements. So it also allows to specify required and optional elements, which is kind of cool. And then associates unique identifier with them. So the unique identifiers are only relevant for the internal representation because instead of encoding all the names, for example, name and ID and email and so on, it will internally just encode field 1, 2, 3, right? For efficiency reasons, so it doesn't need to go over the wire. And this IDL is basically then compiled using protoc, so that's the compiler for that purpose, into a language-specific stub. What was a stub again? We talked about it yesterday. What's the stub? Let me bring up yesterday's stream. No? Or at least that's it. So it's basically a incomplete implementation of the endpoints, right? So you have this IDL, this interface description language on the left side, compile this into a language specific, so that may be C++ or Java. That's kind of a Java-esque output here in this example. But it doesn't really matter, all possible language bindings, and basically provides you an endpoint. Think about it like an object representation effectively, setters and getters and stuff, that allows you to encode this message type. So think about it, message here or person as an object or a class rather, and you instantiate it and just set the individual values, and of course can retrieve it, and then basically just send them over the wire. That kind of is happening under the hood. So you technically never need to do this encoding per se. but internally the representation will just fall back to the simple identifiers that we use. And everything is modeled with efficiency in mind. And the protocol buffers, one of the things that they actually encode, which is really nice, is the idea of backward compatibility. Why is that relevant? And what does it possibly mean in that context?
Not every machine might have the same version. Is it?
Yeah? Yep.
That's
number one. Yeah. Number two. So they're different. Indeed, you're right. There are different versions of protocol buffers, right? 1, 2, 3. Third is the current one. What other issues are usually when you think about, actually negotiating a payload format? Why is that backward compatibility important?
Due to existing software.
Exactly, right? So if you have, you always need to see that in an industrial context, big picture. Then we have multiple stakeholders that use the same kind of format. I don't know, for order submission, for whatever, right? It's a highly standardized format. And if you change that, well, just imagine how many information systems you would need to adapt to actually, accommodate that particular change. You're adding a field, right? You make, or you're adding a new required field, if you like, right? If you have backward compatibility, you can allow the coexistence of older versions of the same kind of interface specification. You say, well, you simply ignore that field from the new specification and the old specification. But at least the framework allows you to do that, right? So you can just say, well, we're running in compatibility mode with legacy applications, so you can just ignore that field. If you have a new application, you can just consider this field. So this makes for nice and graceful transition periods. So that's one of the examples where you see that someone with professional thinking has modeled this approach. So it's not just about the spec itself, but also the practical use and applicability, right? So that's really, really nice. You see that rarely. So if you have slightly different specifications that are somewhat compatible, you would still have a functioning system. So that's fairly cool. And of course, being at Google, you have a large number of language bindings, right? So again, Java, C++, you name it. I mean, because they again have the manpower, the needs, and the diversity of systems and languages to exploit. Go, of course, to build in. I think it's a contrib package in Go, not sure, but it definitely built in, so it's very, very native there as well. So that's the key idea. And the idea is, as I mentioned before, you have some sort of interface description language, highly abstract, not tied to any programming language. But of course, in that language specification itself, you just say which syntax it is, hopefully, and which messages, or let's think about it, classes you actually want to encode in different ways. You type them, you indicate the compulsory versus optional nature of different elements. So, cool, yes. So, and of course, as part of this, you get for free, since you're starting from specification and then generating stubs for actually encoding the use, you kind of have implied validation built in, right? Because you don't start from the implementation, you start from the schema first, right? It's a kind of nice way of ensuring compliance and compatibility, because you generate the language-specific endpoints from the schema already, right? So the validation is kind of built into the generated stubs. So, so that's the outcome usually, right? So you have something like this. So this is kind of a direct correspondence here from an example that you have the messages point line and polyline and so on. And this is how it maps then into this is a C++ binding. Naturally, you can just directly use it, and it usually has setters for that particular purpose. So quite straightforward. So for you, it means multiple minimal intrusion into your system. The only thing, you need to run this compiler in between, right? So specify message file, run protoc, and then use it in your code, right? Please.
About the previous slide, what is an IDL?
Sorry again?
What is an IDL?
Ah, interface description language. Sorry, interface description. So in Android we have one as well. It's called Android NAIDL, Android Interface Description Language. And the idea is here, that was the point with this proto language. That's not tied to any particular programming language, right? That's a think about it like a third-party language just for specifying the message format. Yeah, similar to well, it could be some. I don't want to compare to the other formats because they can actually be used in code, but this is never directly used in code. This is just an input for a generator, which actually generates the endpoint that is used in your implementation. And those interface description languages, basically you kind of abstractly specifying the API for objects in a wider sense, if that makes sense. Does it? Yeah. So you're just specifying the interface, the contract of what you expect to be using and what are certain, requirements, for example, which fields you provide. But this is not directly usable in itself. There's always a processor, post-processor involved that then produces the stubs, which is the partial implementation, that stuff here. Yeah. So this is not IDL anymore. So that's the idea. Right. So. Of course, what does it provide? Well, what else would we expect? Strong typing, we have rich representation and collection types, this whole validation option stuff, cardinality, so everything you would probably expect from a fully fledged industry-ready format. I just want to, the best source is always the original source. I just want to bring that, I think it's the reference anyway that I want to point to. Types. And you see already, I'm just scrolling through the different types they actually support, right? So if you look at it, it's incredibly rich. You have complex structures such as structs, for example, meaning they have embedded primitive types. You have unsigned integers for 32-bit platforms, 64-bit, and so on. Null values, of course. So anything you would probably expect, and also very generic ones here, right? So anything goes, whatever, right? So just any data type can be edited. So it's kind of really flexible in covering its ground for all kind of languages, and it kind of needs to be, because if you strongly type and you want to use it in the context of JavaScript, well, good luck, right? So that's probably hardly of any value. If you use it in a strongly typed area, like more into a Java direction, for example, C++, then you of course require more systematic use of data types, right? And cardinalities, of course, are inbuilt as well. We saw them there. Field cardinality, so meaning how many of those fields can you have. It's also quite nice. You specify a field and the cardinality, so you can repeat the field multiple times in that message directly. So it's quite neat quite neat features that are. So, but that's basically the principle. The thing about the binary formats, usually, again, the effect on you is really minimal. That's more like a design decision to use them or not. Not so much complexity in terms of implementation, because for you there will just be endpoints, such as how do I populate an object and send it over the wire. But you don't actually need to deal explicitly with many of the parsing challenges, because they are kind of come out of the box. Whereas in, for example, JSON case, you have much more intervention opportunities, or possibly even requirements. So instead of giving you the illusion that this is everything that you probably come across, no, it's not, of course, right? So there's a large number of different serialization languages. Apache Avro is another one as well. ASN1, this is kind of for telecommunication systems, so they usually work on the lower configuration layer of telecommunication systems to convey routing related information, for example. Then here we have Beason, of course. What else is worthwhile to be mentioned? Yeah, the common data representation. A few weeks ago I talked about Corba, which is basically one early approach to standardize data types across all programming languages, basically. And that is one of the representations coming out of this. Not actively used. This is health related, so health data related. So sometimes they are really domain specific. Flat buffers is an alternative to proto buffers from Google itself as well. Java serialization. So anything you probably can think of. Yeah? So it's a large number of different serializations. So don't get the impression that we covered everything. I'm just covering some that I think may be more relevant for you in the future. So, okay, having talked about all that stuff, right? So we know quite a few formats right now. What is the question that comes to your mind? Or is there any question left that comes to your mind? Please. Yeah.
It's primarily used for configuration files.
Yeah.
Is there any particular reason for that? Did it branch out to other topics? Or?
Often you only have to do things in VI. JSON is very difficult to work with. With YAML, you sort of see what you're doing.
So it's really close to what you see is what you get second, and there's a lot of editors that actually have support for YAML already anyway. So they support the indentation for you automatically. So if you have a new line, it makes it very, very easy to pass and check for validation. So it's just, the idea is that it's much more readable than any of the other formats. And that makes it so attractive for configuration. I mean, if you recall the Gradle files, if you look at them, they're like super straightforward, no semicolon. hardly any parentheses. There are some parentheses for structuring larger areas. The separation to key value is very implicit because in this case it's just in the YAML case it's generally colon, for example, and so on. So it's much more, even more sparse than JSON. That's mainly the reason there.
What I meant was, is it used for stuff besides configuration?
Yes, there are use cases for also for wire transmission. So that's why you have the different formats. I don't know any big package that uses them primarily, because for now web services kind of default back to JSON in most cases, simply because it's more known and it has, well, simply because it's probably simpler. That's probably the reason, right? If you think about the implementation, you don't need to think about specification as much in JSON than in any of the other formats. But sometimes you appreciate the richer nature. But to be honest, right now I'm not sure about any. But probably it's worthwhile having scouting a bit APIs, web APIs, which ones use YAML. That's perfectly sensible for you to use it as well and try it out, right? But it's just that it's kind of right now more in the configuration side for its legibility. What I want to get is the obvious questions that usually I would expect it. Any other questions, more general, big picture questions? Not specific to formats, but along the lines of why you're telling us that. No, not necessarily, please.
A different question, I suppose. When you make post requests and get requests to a server, what type of format is that data exactly?
Ah, right. So that's the type that is. So you're talking about the IDL, the protobuffer IDL, right?
No, I'm saying like if you're on the web page, like you submit a form or something to a server, right?
Yeah.
And then you submit the data to the server.
Yeah.
Like what is that? What is the thing? What format is actually the data when it gets sent to the server?
Right. So if you that's okay. We're starting. The sending here starts with the post processing, basically, right? So if you, for example, do it in PHP, right? So it's sent to PHP, of course. So then PHP does the serialization and parsing for you. So basically, if you think about format, then it would be configured in PHP before it be sent to server, right? So if you, for example, directly using JavaScript, you would use JavaScript typing. Not sure if that's what you ask. If you asked what happens when I press a form submit button in HTML and it sends to a server, how this is sent, this is regular HTML.
Okay.
This is an HTML form specification. It basically reflects the entire form and sends this as a post document to the server. But so that's still on the HTML side, right? After that, the interesting bit starts. That's where the serialization actually starts and communicates with another web service. If you use JavaScript, it's done in your browser, and then you fall back to the facilities that JavaScript provides, including the types, however strong they are. If you have a server-side processing like JSP, like Java, for example, Java Server Pages, or PHP, of course, right? So you're kind of down to their facilities for serialization.
Okay.
And this comes back to my next point. You're actually on the right track there, because one of the questions that I would expect, well, tell me something about performance. What do I gain by using those different things? Right? So, I mean, why don't I do just everything in XML? Because now that's the richest feature set. I get everything, right? Why don't I just use that thing? Or why don't I just use JSON because it's so lean and small and so on? So the idea is there. Yes, I want to show you give some information about benchmark, but moderate the insights, of course. So benchmark is always a bit challenging. Do you think there's a one-size-fits-all solution? There's a determined fixed answer to what's fastest and what's slowest, or not? And if not, why not? Can I always say JSON is faster than XML? If yes, why? If no, why?
I think so.
Okay, why?
Because in the case of XML, you need 2 tags.
Yeah.
Opening and closing. Also, with JSON, only 1 word.
Yeah.
Whatever's inside.
Yeah.
So I think it's just shorter and does it faster.
Yeah. Okay.
Yeah,
it's one. Yeah. Different position, same position. Who agrees? What could be other factors that would moderate that claim? Well, in the end, Yes, in principle, yes. So purely on the wire, of course. And for pure serialization, deserialization, probably as well. Say it with care. But what happens if your programming languages has stronger typing, for example, basically requires a more specific type specification than you provide in the transmission format, right? You only have the number format in JSON again, and the endpoint needs to figure out, okay, hang on, is it an integer, is it a double, is it a float, or whatever else? And this costs time. So, and depending on your endpoint, operating system, programming language, and so on, and of course number of fields suddenly that require this kind of parsing in your JSON structure, it may actually be cheaper to have more verbose transmission, XML style, and save time on the actual parsing as opposed to transmission. So meaning if you have very fast network connection, it may not matter using actually XML because you lose at the endpoint doing serialization and deserialization.
You're assuming the user has a fast network connection. Right?
That's right. So that's right. So why? So what is your conclusion out of this discussion?
I'd say like you have to go for what's fastest in general,
Yeah.
rather than what's fastest in this specific use case. Unless you can be fairly certain that the user will have a pretty fast connection, I suppose.
But put yourself in an industrial context, right? You're a programmer now, right? So you need to develop something. Which conclusion would you draw? You have a fixed customer, let's say Telenor. Yeah. So what would your conclusion? What would you say? Which format should they use? And you are the guy implementing it.
Yeah. Well, I know that it's them, so I don't know. I guess still, I feel like JSON is just a bit more simple to use.
Okay.
So ease of use for me. So it's I don't know, quicker to do, I suppose.
Yeah.
Like you lose a few seconds on all the parsing, and I don't think that's too much of a setback. I might be wrong though. I don't know.
That's right. So how do you deal with this? How do you put more certainty into the claims? I'm not opposing it. I'm just
ask what the customer might want.
Yeah, that's number one. Yeah. What else?
That's probably the first thing to do.
Yeah, absolutely. I agree. Perhaps there are fixed standards. No left and right. That's possible, of course. What else?
I don't know. Maybe do some mini tests. I don't know.
Aha, testing. Okay, it's not that we haven't talked about it in the past few sessions. That's right. Try it. Right. So that's the key thing, right? Because there's many components, right? We have network performance, right? With connectivity they had, data types, data formats, language bindings they're going to use. How efficient are they, right? So are they really having a shitty binding or a good binding and so on? So it's actually quite important to be aware of what specifics the companies use, right? Or operating systems. So that's why I'm just saying it. Use every time you make assessment of formats and their performance, test it for a very specific use case, right? The message format that you need or that you know. So it's quite of dependent. And I want to run you through one example here. So for example, one of the things that makes JSON sometimes problematic in the practical use case is that it's nearly completely textually coded. So you need to infer advanced formats from it, right? So we talked about this, of course, and we don't have sequential data. What happens if you have a JSON document, right? You only need one specific element of data, right? You don't need the whole thing. You only need, element 50 or something like this, right? Very expensive, because you still need to pass the whole thing to actually get access to it. So again, it boils down to the use case, right? That's the message here. It's not, there's no right and wrong. It's just, you can't just assume that one is better than the other. So in other formats, such as, for example, protobufs, you have indexing, access may be a lot faster, right? So that's the idea here. So testing for your application case, there's just too much in there. And there's major two aspects that are important. One of them is, of course, serialization, deserialization. They boil down to the match of application level or programming language level functionality that you need, types, complexity of representations, and available metadata. And the other one is, of course, size. How expensive is it to send something over the wire, right? So the payload itself. But those usually actually go nicely together, and more often than not, you waste more time in serialization, or quite a lot of time in serialization than you might think. So, so how do you approach it? Well, you generally sample from the real world, right? So you take something that you would realistically transfer from the real world, put it in a benchmark, and try it out. And if you're not quite sure what the sample is, well, sample wide, right? Try representative extremes and a middle ground in terms of sizes, for example, or complexity of payload. And the other thing is also, if you do benchmarks, always report on that one. Which operating system you use, which languages and which frameworks. Because if you do parsing and you don't tell me, you just say, oh, you passed XML or you passed JSON, you're not telling me anything about the language format, you just tell me everything about your parser. right? Because that's fundamentally the kingmaker or not, right? I'll show a little example for that in a second. So I borrowed an example benchmark just to give a feel and to look at different formats. Of course, we have those more efficient one, and we have the slightly more verbose inefficient ones. So protobuffers, Avro and Thrift. So one of them is Apache open source, openly available one, and there's another quite efficient one. And we have our more traditional formats, or human readable formats, XML and JSON. And what they did is they wanted to test it, the application, and they just submitted a tabular format. Basically, think about CSV file style input, right? Of varying lengths, since VSV tabular structure, to test it out. And they did different tests, for example, for small files. So, so this basically shows the file size in megabytes is usually tens of entries in a CSV file and so on. And it basically shows the file size in bytes, just to give a comparison of what's coming out of it. If you encode something, of course, in XML, well, it turns out to be about 8 kilobytes, right? So, and if you see the performance improve to JSON, it's actually it's considerable, right? So it's factor 2, right? So it's nearly half the size, right? That's pretty cool. Get quite an increase. But if you realistically look at the binary formats, I think you need to start looking here. It's a massive difference, right? So we're talking, hang on, that is factor 20, right? So in reduction of size. So binary can actually make sense, right? If you say JSON is cool, well, from transmission point of view, that could even be cooler, right? Anyway, you just notice here, those are different versions of protobuffer, right? So they tested across different versions of Google's protobuffers. Yes, there are performance differences, but usually if something is more performant, usually means has less features. So you know that I haven't looked at the specs, but my suspicion is they introduced additional features, had a minor performance decay, which is still negligible in the trade-off of performance, because you need to compare it to those ones here. Right? So that's for small files. Okay, sounds kind of quite good. So that's file size. The other thing that you want to look at is, of course, serialization times, right? So how long does it to serialize stuff? And recall the fast formats here. We have this Avro thing, we have protobuffers, this Thrift format which we didn't talk about, and our old candidates. And if you look at this one here, who's ending up here? Well, this fancy Avro format is actually in it. With small file sizes, it's very highly inefficient, right? So actually, you waste all your time doing serialization, deserialization. So this file size is very optimal, very small, but is it actually worth it? Well, in this case, highly questionable. So it really depends on how much transmissions you actually do, whether it actually pays off to deal with this offset in performance, right? So it's fairly high. And they also indicate the function that they actually use. So deserialize Avro, they provide the actual implementation as part of it. So, but even compared to this, XML doesn't actually fare too terribly bad, but we still have a considerable decay, so factor, what is it, 5 to 6, compared to the protobuffers that all sit down around here, right? So we have 23 microseconds that we have have for protocol buffers, and quite a bit more actually for the more verbose formats. So factor, what is that? Factor 4 to 5 here, and 5 to 6 is probably for XML. So it's actually not too bad. So the relative differences between JSON and XML is not that large. The relative difference between those ones is the significant ones, right? And if we look at serialization. And here the optimization comes into play, right? Simply having the metadata, targeted access, and things like that. Right? So what they didn't test, though, is different access types. If you, for example, only access a subset of the file, that would be interesting to see in what's the performance decay there. If you do sequential reading or random reading, right, across contents. Small objects, right? So for larger files, so that's the large files encoding. For example, we're talking megabytes, 250 megabytes. For that is hundreds of different entries that they actually had. And then you see a significant win. So again, JSON, roughly factor 2, right? So reduction makes sense intuitively. We lose all the text and have much more parentheses, right? But this here, again, this is fairly homogeneous, I guess. So pretty much they're all down to 40 megabytes. So pretty much you can't do any better anyway, right? That's the highest possible compression you can come up with. And even amongst framework, whatever. I think this difference is negligible. I would never make this a determinant for choice of a framework, because then I would use what are secondary factors that make one of those more or less attractive. For example, compatibility, community, commitment from maintainers. This doesn't justify that enough, right? But this difference is arguable, right? So if you say, I need to decide on a format, well, this difference is much more concerning. Right, so we now have large files, serialization times again, right? So you always need to put both into line, into size. So the file size is of course relevant for the transmission over the wire, boils down to connectivity of course. And serialization is at the endpoints, right? What's happening there. If we look at it actually now, for large objects, this Avro framework is actually doing quite a bit better, right? So if you were to be in a position of dealing with large objects only, suddenly it's back in the loop, right? So it would be an optional candidate for possible use again. And if we look at it from a performance point of view, JSON and XML parsing, suddenly it's not that wide the difference anymore, right? So in fact here I would consider this difference negligible, but let's say they're on par, right? So suddenly JSON is not that much more efficient anymore compared to XML, right? So it really boils down to a specific use case. What, of course, the general rule holds: anything that's human readable is always way slower than that's binary. So that's true for all cases. But within differentiating within cases, it's super important to actually know the kind of payload and data you want to use, and probably apply secondary choices. So we see protobuffer sits around here, so around 1,000 milliseconds. Protobuffer 3, sorry, I'm always looking at that one. And we see, for example, it's quite interesting that there's also considerable difference between serialization and deserialization, right? You know the difference, right? Serialization, deserialization. Yes, no, please. Signal indicator. Else we'll stay 2 more hours, and I'll tell you about serialization. So it's basically serialization is taking a data format as used in code, right? So and transform it so it can be transmitted over the wire. Deserialization is the opposite, right? And sometimes serialization can be faster, but if you, for example, need to do type inference, deserialization, so actually reconstituting your data structure makes me more expensive, right? So, and we see that quite nicely here, that the deserialization of protobuffers here actually takes longer than the serialization. So putting it on the wire is faster than taking it off again, right? Here, ironically, the slowest is always the serialization for both open human readable formats. So quite interesting. But if you look at the factors, we have factor 5 differences here, right? So for large files and serialization types. So, well, what's the purpose of the exercise? Of course, we figured out human readable formats are slower, but I think it's important to look at what's relevant when you make judgments, right? File size corresponds to transmission, serialization corresponds to languages. What we're missing, for example, is, okay, which features actually have been exploited, right, from a particular format, right? Do you really use internal references, for example, right? Do you use complex collections and things like this? So if you, that's an information that, of course, is also relevant for your specific use case, right? And what happens if you have random access to data, as I mentioned before? Those can all be quite different, right? So, I mean, the only general insight is that, yes, binary formats are faster. Everything else boils down to use case. It should be defined by a feature set. Just pointing you to a different benchmark, very brief one though. Here the emphasis is not so much on, again, highlighting the same thing, but rather indicating how much parsing can make a difference, right? So here actually we're dealing with 3 JSON parsing frameworks, right? Those are just the parsers for JSON, and those are, so again, this other framework and protobuffers, right? Okay, what do we have? Compared to Jackson, which is kind of a gold standard, the one we're probably using in this course as well, compared to protobuffers, so protobuffers is around 8 times faster in actually, serializing stuff. Well, surprise, I'm not surprised. What's more interesting is, check the in-between performance between different parsers. Right? You can have a factor 6, up to factor 6 for a different parser. Yeah? So it's really, really hard to pin that to the data format, right? It boils down to just being the parser effectively, right? The relative difference between this one and this one is smaller than the relative difference between different parsers for the same data format, right? All JSON, protobuffers.
Why do we have so many JSON parsers? Wouldn't the faster one just kind of outcompete the others? Or?
Well, the question is, usually that's one of the things, of course. We can have the best parser and so on. So it boils down, okay, parsers, since they are not kind of governed by consortiums, they are specific to programming language, right? So we're talking Java here, right? So okay. Which is true for all of them. So you may not have the same parser available for C++, or it may perform worse or better because of the data structures that are supported, right? The mapping that I just talked about. That's one of the aspects. The second aspect, we don't know about the feature set. So this one may have a much richer feature set than the other ones, but much more inefficient for that very reason, but easier, for example, to use, right? So there's multiple trade-offs that are involved there as well. Perhaps it only supports the subject of the JSON specification for efficiency purposes, right? But you're fundamentally right. You want to look for efficiency there as well, but it's always a trade-off. Another thing is that, for example, would drive me towards Jackson every time is big community, heavily supported, long-term maintainability. Check mailing list, you find something. Try it with this one, good luck. So maybe like 2 people using that thing, right? So yes, you're right, but that's not how it in practice works, right? So that is community-driven, boils down to programming language and your needs effectively. But it's an interesting insight. I found this quite interesting just to see the difference here. Not this stuff here, that was expected anyway, right? But here, the magic. So, and then, you know, if you scale it up, it roughly stays the same, but you actually lose the benefit on different JSON parsing mechanisms because they just extend fields, so it's not that much of a performance gain there anymore. So you also need to bear in mind, okay, which sizes to use, right? It's always the sizes, which programming needs with endpoints and so on. I don't want to push it much further, but those are important things that are kind of really relevant for you. If you ever want to make, want to do benchmarking, figure out what is a representative use case, sample from it, specify everything you have, figure out the differences between size and serialization, which is particularly important for transmission, the size one, and of course run multiple and take averages. That's the outcome there. Okay, which format is the best? Good. Okay, I want to get you that one. So I think I succeeded. It depends, right? So it's no right and best. So it's a bit of a summary here. You know, it's basically the idea. We have schema support. We have human readability for XML, variable both, redundant text, JSON human readable, concise, no schema support, quite straightforward. YAML kind of the world in between, right? So we have richer typing. It's more efficient, but we don't have explicit validation, but third-party stuff for YAML. Protobus, backward compatible, binary format, so not human readable, but has all the nice features that we know from XML. So it's really quite a diversity and elements to choose from that you can see. What do you do? Well, for choice, feature set and readability is important. You know, is that important for you? That's basically all just questions. Is that relevant for your application case? Performance, what kind of performance? Serialization, transmission, support. Is there community around it, right? Are you the only one doing it? Are you writing your own, rolling your own? Good luck with support. And compatibility. How many future potential business partners will you have that use the same environment? And that should be a decisive point as well. If you have hundreds, well, better go for something that's well and broadly supported. If you know, okay, you're only dealing with the same kind of web service every time or the same kind of interaction party, you can narrow down your openness, of course, right? So that's the key thing. Okay, sorry, it took a while. Overshot a bit, I guess. Questions? Have you heard all that stuff already? Because I always need to check that out here carefully. Because people actually, they just bear through 1.5 hours of boredom and then say, yeah, no, I know that. You know, so that's always good to know. But anyway, I just wanted to, what I want to have you to take away is like, it's not black and white, right? So it's also not just a progression, what's trendy, what's not trendy. It's actually a very use case specific decision you need to take, right? And try, test it. There's so many factors in it, right? If you really need to make the call, don't think you know everything. That would be just blunt assumptions. You need to explore and test it for your specific use case. Cool. If there are no other questions, then you're free to pursue whatever you pursue on a Wednesday afternoon, morning, or lunch, I guess. By the way, there are no dedicated lab. Well, there are still lab hours from 10 to 12 on Thursdays, but there's no specific and declared lab sessions anymore. I send an announcement on an issue basically that you will need to kind of make appointments in a wider sense. Use a certain label and say, hey, I want support on a Thursday, and then the tutors will attend to you. But of course, there will be no set program. But you make the program by saying, hey, I have this problem. Please help me, right? Because we had relatively low attendance, that doesn't really correspond to the effort that they put into preparing for that very session. Yep. Bear in mind for your assignments in particular, because once we're getting closer, there will be kind of peak demand, right? So it may be challenges satisfying the demand. So use the time right now wisely, even though the deadlines are far out.
Is the lab for assignments that